All right, today we're going to peel back the layers on something we use every single day, software. And what we find underneath might just completely change how you think about what it even means to program a computer.
So let me ask you something. When you hear the word programming, what's the first image that pops into your head? Seriously, picture it. For most of us, it's probably the same kind of thing, right?
Yeah, you're probably picturing someone hunched over a keyboard, maybe in a dark room with lines of code just flying across the screen. And look, for modern programming, you're not wrong. But what if I told you that the very first programmers never touched a keyboard, that there was no screen and no code in the way we think of it at all?
To really get what I mean, we've got to jump in a time machine. We're going way back to an era where computers weren't about abstract ideas. They were quite literally machines made of wires. Okay, so try to picture this. You walk into a room, and it's just filled with these huge metal panels, tangled webs of cables, and rows of switches. There's nothing to type on, there's no monitor to look at, and there's no such thing as software to run. The machine itself, well, that was the whole thing.
So, how in the world did you make it do anything? Well, you had to physically change it. I'm serious. To program the computer meant literally getting your hands dirty and rewiring it. Every single wire was a connection, a piece of logic. And if you wanted to change the logic, you had to change the wires.
I mean, the difference between then and now is just wild. Today, you want a computer to do something new, you open a file, you start typing code. Back then, the job was all physical. You were unplugging these thick, heavy cables, figuring out where to plug them back in, flipping dozens of switches. It was much more like being a telephone operator or an engineer than a coder.
And this whole process was so incredibly slow and deliberate. The programmers, who, by the way, were very often teams of brilliant women, would start with these massive paper diagrams. From there, they'd have to go to these huge patch panels and physically move all the wires to match the diagram. Then they'd set hundreds of individual switches, and only then, after all that, could they run a single calculation.
Just let that sink in for a second. Every unique setup of those wires basically turned the entire machine into a one-trick pony. It became a hyper-specific calculator that could do one thing and one thing only. Want it to solve a different problem? Well, guess what? You had to tear it all down and start the whole rewiring process from scratch.
And we are not talking about a few minutes of work here. Setting up one of these machines for just one new problem, that could take hours. Sometimes it could take days of meticulous physical labor.
And can you imagine the pressure? There was no error, syntax incorrect on line 42. No helpful feedback at all. If you plugged just one of those hundreds of wires into the wrong socket, the machine wouldn't tell you. You'd either get complete nonsense spit out at the end, or you'd get nothing. Absolutely nothing. Your only option was to go back and physically check every single connection you made.
So this physical, almost mechanical way of computing was the norm for years. But then something happened. A huge revolutionary shift that changed everything. And this, right here, is the moment that software as we know it was truly born.
You can really see the evolution here. It was a journey away from the physical and towards the abstract. We started with literally wiring things directly. Then we got a little smarter with switches and patch panels, which made things a bit faster. But the real game changer, the big leap, was when we figured out how to store instructions electronically inside the machine itself. That paved the way for all the layers of complex software we have today.
And that's it. That's the birth of software. The instant that instructions could live inside the computer as electrical signals instead of as physical wires, that's when programming stopped being about building a machine. It became about writing symbols, about pure logic, about abstraction.
But here's where it gets really cool. Here's the twist. Just because we started writing symbolic code doesn't mean that physical machine just vanished. Oh no. In fact, that old world of wires and switches, it's still there. It's just hiding right beneath the surface. So, the big question is, did all those wires just disappear? Well, the answer is kinda no. They just became invisible to us. Think about it. At its absolute most fundamental level, your phone, your laptop, it's all still working on the same basic principles. It is a machine of physical states. Billions of tiny electrical signals are either on or off, there or not there. Those connections between components are still totally real physical pathways. So what's the difference?
The mind-blowing difference is the speed and the automation. Instead of a person spending hours plugging in a cable, we now have tiny little switches called transistors that make and break those same connections for us. And they do it automatically, controlled by our code. Millions, even billions of times every single second. It's insane.
And this really brings us to the main idea, the big takeaway. What feels to us like typing code into a text editor is actually kicking off a massive, unbelievably fast, invisible rewiring process happening deep inside the guts of the machine.
You know, all the magic of modern software, how flexible it is, how powerful it is, it's really a beautiful illusion. It's an illusion built on top of layer after layer of abstraction, all designed to hide that rigid, mechanical, physical foundation that everything still runs on.
So the next time you fire up your computer or open an app, just remember this. Those early programmers, they weren't writing instructions in the way we do. They were literally shaping their machines. And in a very real, fundamental way, every piece of software we write today is still doing the exact same thing. We just don't have to touch the wires anymore.